Hi guys, my name is Josh, and today we're going to be talking about chemical reactions. So let's look at this. You eat a piece of cake, right? You keep eating it like this character from Matilda who just keeps and keeps eating it, right? And he clearly his hands are getting messy. So when your hands get messy, you go and you wash those hands, right? So initially your hands were messed up with cake, right? Really messy, and then your hands became squeaky clean. From this messiness to squeaky clean, that is what we call change. Let's look at this. Can you breathe in? Take a deep breath in, and that wind that is coming into your mouth is oxygen. So let's imagine that you are this oxygen, right? You go get into grade 8 in the first time, and you haven't met many people, and you might be feeling a bit lonely. But as you progress in grade 8, you realize that you make more friends and there's a change that happens, and now you're part of a group and you have friends. Your friend's name, as you can see there, is also oxygen. Right, now we move on. Can you stick your one finger up? Right, then can you stick two fingers up? That is simply what a chemical reaction is. Don't overcomplicate it. It's simple. Chemistry is simple. Now, let's look at a high five. So you're going to give your friend a high five. Let's call your hand hydrogen and your friend's hand oxygen. And now obviously you're not just going to sit there with your hands up not giving each other a high five. So you go in for the high five and your hand hydrogen moves in and his hand oxygen moves in and clap, right? And you give each other a high five. And that is simply what a chemical reaction is. Right. Let's look at Mickey Mouse, this blue Mickey Mouse. Right. He is blue, but then you go into the shop and you find this green Mickey Mouse. Can you see the color change that happened from blue to green? Right. Have you ever farted underwater? Be honest with yourself, right? So it may have looked something like this, right? Where there are these many bubbles in the water, and those bubbles are basically gas, right? Let's look at this dinosaur made of water. Just imagine this dinosaur made of water. But we all know that dinosaurs are not made of water, they are rather solid. So this is a solid dinosaur. Solid is important. Now, let's look at this piece of meat, right? So say your mom puts a piece of meat into the oven, but you can't really smell it, right? Or it doesn't really smell the best. So after some time when the meat is cooking, you start to get hungry and it starts to smell really great, right? Smell is important. Now, let's look at this. Can you rub your hands together? Just rub it, especially in South Africa in the winter you'd want to rub your hands together. And why is that? Because as you rub your hands together, your hands get warmer. Right. Let's look at this. As you can see, it's popcorn. So you take some popcorn kernels, you throw it in the pot with the oil, it starts to sizzle, and then pop, pop, pop. We can hear that popping sound. We can hear the popping sound. Right. Now, let's look at I'm sure you're aware of Superman. So this is Superman's cape. Let's call Superman's cape Atom 1. And now let's call Superman's back Atom 2. So we want to help Superman, so we put Superman's cape, Atom 1, onto Superman's back, Atom 2. And that is simply what a compound is, right? Now, Superman, he goes, he flies, he fights crime, he comes back, and now he doesn't wear this cape all the time. So, just like how you may take off your shoes after a long day, Superman takes out his cape. So, Superman's cape, we help him, we take off his cape, which is, remember, it's Atom 1. We take off his cape, Atom 1 from where? From Superman's back, Atom 2, right? Then, are we going to throw Superman's cape on the floor? No. So where are we going to put it? We are going to put it on a hanger. And let's call that hanger Atom 3. That act of taking Superman's cape off of Superman's back and putting Superman's cape onto a hanger being Atom 3, Superman's cape being Atom 1, right? That is simply what a chemical reaction is. Now, let's look at a burger. What's your favorite burger? KFC, maybe it's homemade, maybe it's McDonald's, maybe it's Wimpy. These things are usually in a burger. Butter, lettuce, buns, patties, the best part, sauce, cheese, right? These things are in a burger. We can call them the ingredients. Let's call that ingredients hydrogen and oxygen, or we can call it reactants. So these ingredients, we obviously need to collect them before we can make the burger, right? Makes sense. Now, we're not just gonna leave these ingredients, sitting there, not doing anything. No, we're gonna put them to work. We're gonna do something with them. Those ingredients being, remember, our hydrogen or oxygen, or we can also call them reactants, right? So what we're gonna do is we're gonna take those ingredients and we're actually gonna make the burger. Right? So we're going to take the ingredients, lettuce, buns, or we could call it reactants, and we're going to make the actual burger, put it into the burger. So when we put it into the burger like that, we call that a chemical reaction, right? So putting all those ingredients into the burger is called a chemical reaction. So after we finished putting all the ingredients together, what do we have? We have this beautiful burger, right? So here is our burger, which we can call H2O, right? Simple. Burger H2O. And we can also call this the what? The final product. Thank you guys for watching. Don't forget to like, subscribe, and comment, and see you in the next one. Bye.